Alrighty, welcome guys. This is going to be a walkthrough for editing the North American Nebula and the Pelican Nebula in the Cygnus constellation. This is my first video walking through some astrophotography editing and stuff. This is mostly just for people who ask a lot about my work. I am by no means the best, and this is definitely not supposed to be a tutorial in any way, since I don't know nearly enough about this stuff to really put together a good tutorial. And there's some really awesome stuff on YouTube relating to the software and the techniques I use here that can explain this stuff way better than I can. So this is just going to be a brief overview for people who are curious about how I go from doing hours of exposure outside in the middle of the night to the final product. So real quick, we're going to open up Stellarium, which is a really cool free program that you can kind of explore the night sky with. So anybody who's interested in astronomy or astrophotography or anything can download it and kind of explore what kind of stuff you can get in the night sky and what's really up there. So we can see here, this is a different time and day than when I shot these original frames, but we still got our target here. We're going to zoom straight in on it. This is, if I turn on the constellation lines, you can see Cygnus is here, pretty large, kind of right smack in the middle of the Milky Way. And there's a lot of really cool stuff, which is partly why I chose to target in my last run to a dark site. You can see this is my framing right here, roughly, which is about the size of Canon 6D at 135 millimeters. So that's a full frame DSLR at 135 millimeters would give you roughly this this field of view right here. And I chose it mostly, I didn't include the Veil Nebula because that was kind of out of the way, and its surface brightness is so low that I don't think I would have got a lot of data on it anyway. But I really wanted to get the North American Nebula here, the Satyr region, and of course the Crescent Nebula, which is really fun looking, although I didn't have necessarily the focal length for it. So I got this whole region right here, including a bunch of dark nebula and stuff like that. So that's roughly what we're going to be looking at, what we're going to be expecting to see. And Stellarium doesn't really give you a good idea of how bright these regions are. The North American Nebula is definitely one of the brighter regions in this area, but you can barely see it here in Stellarium. So we're going to go ahead and exit out. And we're going to open up Deep Sky Stacker. So I'm going to walk you through basically the light frames that I put in and all the calibration frames that went in. And for those of you who don't know what those things are, I'll just briefly talk about them and then we'll get into the final image. So first we're going to open up our picture files, or what's called the light frame. We can see I already got the thing opened up for Cygnus. Light frames are basically just the raw data, the stuff of the subject at the settings that I wanted, and then that's it. So we're going to open up all of these ones. There are, I think, 76 of them. We're going to go ahead and check them all real quick just to kind of explore them, and then we'll open one up and I'll kind of show you what's going on. This is pretty much what happens right outside my camera, or what I get right outside of my camera. Not a lot going on. You don't really see all that much, which is why the stacking process and calibration frames are so important, because the raw image that you get out of a camera often isn't the most that you can really get. So you can see here just barely the North American Nebula kind of in the corner here with the Pelican Nebula, and you don't see a lot of detail at all. We're going to see a lot more of that later on when we actually get the full stack. And this is the Satyr region here, and then just barely visible right here is the Crescent Nebula, and that's really all I wanted out of this shot. And the framing is really easy because these two really bright stars here is really easy guide for the framing. So those are all of my light frames. We're going to go ahead and open up our first batch of the calibration frames, which is the darks. And darks are basically shot at the exact same settings as light frames and the same temperature, usually right afterwards. That's done, stacked together to subtract all of your noise and heat and all the other problems that you might get while exposing on your target, and subtracted from the light frames to give you the best signal to noise ratio. So we're going to go ahead and open up all the darks that I took, and I took a lot of darks because I think I fell asleep while the darks were going, and then we woke up in the morning to leave. We're going to go ahead and open up a master flat. I don't have all of the original flats because this is a few weeks ago, and about a week before I actually took the light frames, where my lens didn't change all that much. If we open up the flat, you can see this is a little bit different than dark frame. Dark frame is just going to be all black. There's going to be no data. Yeah, so you can see here there's really just nothing here. But if I were to stretch it, as in change the histogram in some way to bring out detail, you can see there's a lot of like hot and colds and dead pixels here and a lot of noise, and that noise is what I want to subtract. A flat frame is very different. A flat frame, you can see the vignetting pattern of the lens, and the Rokinon 135 actually doesn't have a lot of vignetting, but it's enough to where I still want flats to take care of it. It's also going to map a little bit of dust. You can see here, I think I have a dust mode somewhere around here, and I really want to take care of all of that because dust on the sensor or the lens is going to mess with the intensity of that particular area. So flat frames are basically taken against a bright white even light source like the dawn sky or the dusk sky or like a laptop screen, and at the same focus as stars to get the right vignetting pattern and the right dust pattern. And the ISO doesn't necessarily matter, but the exposure to keep it at an even value does kind of matter, and that's pretty much it. So this is your master flat. This is generally what it's going to look like, where you have darker areas around and then lighter area in the middle, and that's what we're going to try to subtract with the master flat. Then we're going to open up a master bias because I have about 250 of them and I really don't want to stack them all again, so we're just going to open up the master version that I already have. This is going to be shots taken at the same ISO but the fastest exposure that the camera is capable of, which in the 6D's case is going to be 1/4000th of a second. And with the lens cap on, so it's only going to be capturing basically the internal noise and circuitry of the camera itself, and subtract that stuff. Less important, but still worth it to throw in there, especially for Canon cameras that have a lot of banding. So we're going to take care of all of that stuff. So with all of our frames there, we're going to go ahead and open up the register thing right here. Now this I'm not going to go through again, but because you can see I already have them scored. Registering is going to score each of the frames based on things like how tight and in focus the stars are, if there's any star trailing, which is blur, and that will affect the quality of your images, or if the signal to noise ratio is too low or high enough, it's going to score them based on that. And you can change it based on the star detection threshold. And I have it perfect the way it is, where it's just detecting anywhere from 2,000 to 3,000 stars, which makes for really good alignment and a really good scoring. So we're going to go ahead and hit stack checked pictures. We're going to go through the settings real quick. I'm actually going to open up a light frame first, the best light frame, scored at 20,000 or so. We're going to go ahead and select with the red marker right here. I want to capture the North American Nebula, the dark nebula around it, and the Pelican Nebula right here. That's what I want to work with. I've already done a few shots of the entire region, but I really want to focus on this because I think I can do a lot better job with it. And if we go to stack check pictures, you can see the stacking mode is changed to custom rectangle, and I can switch it to standard, which would stack the entire image, but I just want that. And I'm going to enable ×3 drizzle, which I am definitely not going to get into because it is super complicated, and explaining it would literally make anyone else's understanding of it even worse because I would be absolutely terrible at it. But basically what it's really going to do is just to blow up the image to a larger resolution while retaining some modicum of detail. It's best used in conjunction with dithering, which is another process that I'm not even going to pretend to understand, but basically it's just moving the sensor around a little bit in relation to the stars to give you a better kind of sampling of your target. We're going to keep all that stuff the same. We're going to go ahead and hit recommended settings just to see if anything is off. We don't have super pixel mode on, which is good. We want bilinear debayering, which I'm not even going to pretend to understand. And then we're going to keep kappa sigma clipping. The other one, the auto adaptive weighted average, is basically just going to weight other frames more based on their score. All of these frames, I inspected them and they're all really good, so we're just going to stick with kappa sigma clipping. There's no need to do a weighted average. And then these we're going to unselect because I want to mess with the colors afterwards. All these are going to do is just Deep Sky Stacker is going to mess with the colors to make it background neutral, and I want to do that later on in the process. So we're going to unselect those. Anything that's blue is unselected. Anything that's green is selected, basically. So that's all good, and we're going to go ahead and start the stacking process, and this is going to take a while, so I will go ahead and fast forward into the future and show you guys the final project. Alrighty, so that stack was now finished, and now we can see here that we have a lot more data in signal to noise ratio than we had before. The colors are still a little weird because I told Deep Sky Stacker not to mess with any of the colors or do any background calibration or anything, because I want to do that better in Photoshop using some other tools. So this is a really good indication of the data that we're going to be working with, and it's some really awesome data. I really like how the Cygnus wall came out. Lots of really cool filaments and dark nebula going through here, and the Pelican Nebula looks really nice as well. You can see this huge region right here looks really clustered, and lots of stars seem a little bit blobby. I shot this wide open at f2. The widest aperture that my lens is capable of, which I shouldn't have done. I probably should have stopped it up a couple times, make the stars a little bit tighter, a little bit sharper, get some cool diffraction spikes going on the larger stars, but I decided not to do that, which kind of bit me in the butt a little bit here. But you can see, regardless, the image turned out really nice, and shooting open at f2 allowed me to get a lot more light onto there than I normally would have. And since the payload is 60 plus the 135 lens is really heavy, I could only stretch the exposure so long before my tracker was just, suffering from some major problems. So this is pretty much as good as we're going to get it. I'm going to go ahead and save this, save to file. We're going to go ahead and call this 76 by 1, actually no, that would be 75 seconds. And we're going to call it times 3 drizzle RGB. Just to get the most amount of information in there, because I got a lot of stuff in there. You can see if we go to the Cygnus folder, we're going to save it here. Boom. And then we're going to go ahead and open up our hydrogen alpha data and start stacking from there. So I'll see you guys in a second. Alrighty, so we are now on to the hydrogen alpha part. Now, before I kind of get into all the stuff in Deep Sky Stacker, I just want to explain what's kind of going on mechanically, image-wise. So I got my camera modified, and what that modification entailed was removing a filter inside the camera called UV-IR cutoff filter, and that filter is responsible for color balancing for like daytime images and stuff like that by removing as much ultraviolet and infrared light to give you a more natural looking thing, and to make sure focus remains right. Unfortunately, the side effect of that is that it cuts down on a particular wavelength of light called hydrogen alpha, which is at about 673 nanometers. Pretty close to infrared, but not exactly infrared. That UV-IR cutoff filter cuts down the transmittance of that by to about 25%. I got it modified and replaced with a new UV-IR cutoff filter, which passes hydrogen alpha at 673 nanometers by about 100% or 99%. So drastically improving the amount of amount of photons that I get from that particular wavelength of light. Now I still have to deal with things like the Bayer matrix, which is in every single DSLR camera, and the Bayer matrix is really awful for astrophotography because it cuts down a lot of blue and red light in the night sky, because about half of the Bayer matrix is green, and there's virtually no green in the night sky. So you're already not off to a great start, but that modification allowed me to get more than I normally would out of hydrogen alpha targets. And the cool thing is that North American Nebula is almost entirely hydrogen alpha, with a bunch of dark nebula in there as well. So this is a really cool opportunity for me to basically use the modification to my camera to get the most out of the North American Nebula. Now, in addition to that, I also went ahead and got an additional filter that I can clip in to the camera right in front of the mirror, called a hydrogen alpha filter, and it's about 12 nanometers. So it narrows in, cancels everything else out except for hydrogen alpha. What this allows me to do is basically take data of hydrogen alpha and then merge it with the RGB data that I would take normally without the filter to get more contrast on that particular wavelength of light. Now, over the course of about 4 or 5 nights, I acquired a ton of hydrogen alpha data using the filter. So a lot more than the dark side data I got over there. The really cool thing about the hydrogen alpha filter is that it cuts out everything except hydrogen alpha. Moon glow, light pollution, really awful things that happen that prevent you from getting the most out of your images. So I was able to image and photograph here deep inside the red zone of the Bay Area, even during the full moon, and still get really nice detail out of the North American Nebula and the rest of the Cygnus constellation. So that's what we're going to be stacking now, is all of that data together and get a final result, and then we're going to merge that later in post-processing with the RGB data that we had just stacked. So we're going to go ahead and get started. Now, since it's from multiple nights, what I'm going to do is I'm going to sort this. We're going to do this, and we're going to go to more, and we're going to sort it by, we're actually just going to take the days. We're not going to worry about the settings or anything like that. So this is the 31st, and we're going to go all the way down to, so it starts at 11 p.m. and this first night of imaging, 6/1 all the way until 6/2 at 10. So we're going to do all of these ones as our first. And we're going to check all of these. Okay, so we're going to get rid of these two right here right off the bat because they're at 45 seconds. Likely test images. You can see it's all red here. And it's red because hydrogen alpha is actually inside the red part of the visible spectrum, very close to infrared. So the Bayer matrix is going to interpret it as red. Although when we finish stacking it, we're going to change it to black and white to increase, contrast and stuff like that, and then merge it as a channel. We're going to get rid of these because those were likely just test images to see what my exposure could be like. And the rest of these look like they're the same ISO and exposure, so we're going to leave all those the same. 166 minutes for that first night. That's really nice. So what we're going to do is we're going to go ahead and open up dark files that we might have for that particular night. We're going to go to Cygnus in our hydrogen alpha folder, darks, 6/1. Looks like we're gonna, so we're gonna take these because these were probably taken. The times look right, so we're gonna take these for that first night. And for flat frames, let's see, astronomy, 9.2 2.0 flats. I wonder when these were taken. This is a really bad part. 9/1, so these definitely aren't the flats here. Cygnus, HA. Looks like we got the flats right here. Cool. And it looks like these were taken on the first. Yeah, so we're gonna take these, highlight them all, get those in there as on that first batch, and then we're gonna go ahead and open up our bias frames. Now if we were to open up these flat frames, actually, we're gonna go ahead and change the score, and then we're gonna go down to our flat frames. Flat frame is going to look very different. They're actually going to look red. I have it changed. We're going to switch it down just a little bit. You can see the dust patterns a lot more. And you can see the vignetting pattern is actually a little bit different because the filter is there. It's not just the vignetting pattern of the lens. Now we have to deal with the shadow of the filter itself, which actually causes a little bit of a problem because unfortunately we can't get all the amount of information, but this is going to be good enough. We can see there's the dust mote here and a dust mote here, which is much more obvious here in this flat frame than it is on the previous one. So this is very good. Flats are going to be very, very, very critical for this particular process. So we're going to keep all of these, and we're going to go ahead and open up our last calibration frame for the first night, which is the offset. It looks like we shot at 1600 ISO, so we're going to go ahead and grab that 1600 ISO master bias again. And then we're going to go ahead and switch to group 1. Now for group 1, we're going to add the second night of imaging, which I believe was the night of the first in the morning. Actually, no, it was the second. Yeah. So the next day, the day after that, we went out for the second. And it looked like we ran all the way until, well, after midnight on the 3rd, all the way till, let's see, looks like that's actually all of them right there. Yeah, so it looks like it was just the 2 nights of imaging. But it looked like a lot more because it ran from the 31st all the way until the 3rd, between 2 different nights of exposure. So we're going to open up all of these here into group 1. We're going to check them all. And we're going to go ahead and just inspect one of them real quick just to see what it's looking like. Adjust the exposure just really slightly just to see what's going on. These are a little bit darker. I think these were darker because I shot at a full moon on the first one. You can see already there's a lot of really awesome contrast just in a single exposure of this particular target. So that's really nice. We're going to go ahead and open up dark files that we might have for this particular target. I don't think we do. I think what I ended up doing is using the same dark files as the previous night, which is really bad, and you don't want to do that. So actually, I'm going to go ahead and skip that. We're not going to add darks for this particular one. We are going to add flats, though. Flats are going to be really important. We're going to go ahead and add all the flats for this particular night. That's going to be really important. And then we shot this second night at 2000 ISO, different from the 1600 ISO. So we're actually not going to do any bias either for this particular one. We're just going to add the flats and hope that with the massive amount of frames that we have and the massive amounts of integration time that we have on this particular target, that's going to outweigh the weakness of having that extra 100 or so frames without any darks or bias. Hopefully that will work out for us, because I feel that stacking these with the wrong darks is going to hurt us in the long run, rather than stacking and hoping that dark optimization will work for us at a different ISO. So we're not even going to bother with that. So we got our two sets of data. The really important one is the flats, because you can see here just in a raw frame, like the vignetting and shadows of the filter are really bad here, and actually not the best framing if we want to deal with the North American Nebula. If we go to a different one, because it drifts around because my balance isn't right, you can see it kind of changes a little bit, but definitely not ideal. So we're going to keep that the same. Then we're going to go back to the main group with our best exposure, and we're going to go ahead and use that framing. Yeah, that looks good enough. Should be able to, yeah, that should be fine. And then we're going to go ahead and check our settings. We're at ×3 drizzle, which is good. ISO speed not matching with light frames. That's for our offset. Yeah, so we don't want to use that. Yeah, it wants to use the same offset. So I guess we're going to have to deal with that. And then, yeah, so it looks like it wants to do the same thing with the ISO 2000 for the darks as well. So we're going to go ahead and do dark optimization for that, because we really don't have any choice. Flat frames, yep, that's fine. So this is going to be a grand total of 6 hours and 6 minutes of exposure. This is by far the most amount of exposure I've ever really put on a target. Hopefully we'll get some really awesome results out of this, even though that we don't get ideal settings for everything. So we're going to go ahead and hit recommended settings, because we're going to change a couple of these. Since we're doing hydrogen alpha, we're going to be switching to super pixel mode. We don't want to be doing bilinear debayering. Per channel background calibration, we're going to go ahead and select that as well, since we're doing hydrogen alpha. And since we're doing use sigma clipping method or auto adaptive weighted average, we're probably going to change this to auto adaptive weighted average, just because we have 2 different nights of exposure, and we want to keep the ones that actually have the best information. We want to weight those more than the rest of them. And then we're not going to mess around with these at all, because color isn't going to matter. These are bicolor. So we're going to go ahead and hit OK on there. Everything else looks fine, so we're going to go ahead and hit OK, and we're going to get this stacking party started. This is going to take a really long time. Let's actually just see what the offset. Actually, it's going to take a really long time just to get past the offset and into the stacking process, but I'm willing to bet this is probably going to be maybe a half an hour journey, which is a lot more than the other one. So we're going to go ahead and fast forward in time, and I will see you in a second. Alrighty, so we are back. Fast forwarding in time quite a ways. I ended up changing some settings here for the hydrogen alpha portion of the North American Nebula. The first time around, auto adaptive weighted average didn't work out too well, so we ended up switching that out to kappa sigma clipping without super pixel mode. I wanted to keep the scale the same, so we would have an easier time overlaying these in post-processing. So we're just going to play around with the linked settings real quick, just to see what kind of image we're kind of working with. So we're going to move these up just a little bit, just see what kind of detail. And already you can see it's some pretty amazing contrast, particularly in the hydrogen alpha and dark nebula. But yeah, this Cygnus waltz is some of the best detail I've actually seen in this particular shot, at least from my equipment. I've seen some really awesome versions of this particular target, so we're gonna go ahead and nope, we're gonna go back here and save this, and we're gonna call this 366 times 60 times 3 drizzle. Might seem a little redundant to name everything, but we're going to call this HA, just so we know where everything is, what everything is in the folder. Alrighty, so we're going to go ahead and close this out. We're going to open up our folder. We're going to go ahead and open up both the hydrogen alpha in Photoshop, and we're going to open up, once Photoshop is booted up and ready to go, we're going to open up the times 3 drizzle for North American Nebula. Where was that? As you can see, I've kind of gone back and forth with a lot of different edits and settings for this particular target, but this is the first time putting together dark side data, times 3 drizzle crop of the North American Nebula with the massive amounts of hydrogen alpha data that I have. So this should be a relatively new experience. So we got Photoshop booted up here. I'm going to go ahead and move this to our other screen here. There we go. And then we're going to find our other one. It was too bad right there. So a little bit darker, a little bit nicer on the eyes. Still have that really nice contrast in the dark nebula, and yeah, I think we're kind of leave it like that. There are way better people in the community that can handle something like this way better than I can, and I'd love to see what somebody else with much more skill than I do can do with this data. So yeah, if anybody wants to take a stab at this data, let me know. I'll send them a Dropbox link, and both the hydrogen alpha and the RGB data, I think it was, other than shooting wide open, I think they're pretty good data sets. So if anybody wants to take a stab at it, let me know. If anybody has any questions about the process or anything like that, also feel free to let me know. I've been doing this for a while, but I still feel very new to all of this. There's so many smart people out there, and yeah, it's pretty crazy. But yeah, so that was my first YouTube video. So part of my passion for this particular stuff is really just in astronomy, and I love exploring deep space. So this next part, I might as well just talk a little bit about this particular target, since this is not just a bunch of just pixels from a camera. This is real stuff. This is really up there. This is something that people look at in the night sky every night without really knowing about it. So I figured I might spend a little bit of time talking about what we're actually looking at here. So one of these stars, I'm not entirely sure which one. I believe it is cropped out. I think it's up here somewhere, is a star Deneb. Deneb is a particularly bright star, and it's actually the end of the Cygnus constellation, which is where the North America Nebula and the Pelican Nebula is, which is Pelican and North America. Speaking of which, I'd really just like to do an aside. If anybody could let me know how they really look at this particular target as the North America Nebula, because how I see it is, I see this as the border between the United States and Canada, and I see this as like the Great Lakes, and I see this as like the eastern coast going all the way down to Mexico, and then like the border between Mexico, and then this is California right here, like that. That's how I view the nebula for some reason. But apparently I just recently found out that it's actually not. It's supposed to be like all of North America, which makes sense because it's called the North America Nebula, not the United States Nebula. And this is supposed to be Mexico here. And then this is supposed to be the United States, and then Canada up here. But that seems a little weird to me. They should just call it the United States Nebula or something. Not that I'm like overly patriotic or anything, although I am a little patriotic. It makes a little bit more sense. Like if you just tilt your head just a little bit, it looks a little bit more like United States rather than the entire continent. But anyway, so this is a hydrogen alpha emission nebula with a little bit of hydrogen 2 stuck in there, ionized from some star. It might be Deneb, and the process behind that is basically just lots of clouds of diffuse gas, and it's basically being ionized by a star. Now the cool thing about this is that it's not really two distinct nebula. This darker area here that we've been trying to kind of coax out through editing, kind of strings along all right here. This dark nebula is actually much closer to Earth than the North America and Pelican Nebula is, and it's actually blocking the light. It's totally blocking the light between it, and the whole nebula is actually found behind it, and it's this whole region right here. That's actually the whole hydrogen alpha complex. But we see it kind of divided into two because of this dark nebula right here, which is really interesting. And that part of that dark nebula is actually part of the Milky Way, since this particular target is kind of right smack in the middle of the galactic arm, stretching up in the night sky. This particular target is pretty close to Polaris, so being in the northern hemisphere, this particular target's actually up for large periods of time. I really wish I could have got more time on it. I obviously still can, but I really want to keep the framing the same, and it's past the point where I have to switch my camera around, and I don't have a good balance on it to get that going. But anyway, so this particular region right here is called the Cygnus Wall, and I don't really want to zoom in on it too much because mine looks awful, but there's some really awesome Cygnus Wall pictures out there. There's really awesome little details in this particular area that I didn't get out at all. Little tiny clouds and pillars of dust and stuff like that, and gas. But that's one of the most defining features of this particular target is the Cygnus Wall. And there's a little tiny other one right here, but it's a minor one. This whole area right here I've seen more in narrowband imaging with like CCD cameras, comes out blue. There must be like a lot of oxygen there or something like that, but I don't know for certain. Somebody can easily correct me on that. And we can see here there's a lot of really cool tendrils and lots of little tiny other dark nebula coming out from this massive construct of gas and dust, and I feel like it really looks really cool as kind of a backdrop, a front drop, I suppose. And it's through the whole region too. The wide field, which I can pull up here, I think I have my, let's see, the whole wide field area looks really nice, and there's a lot of really nice dark nebula in it. As you can see here, I didn't edit this one very well at all, but you can see this is the North American Nebula here, and the dark nebula kind of just stretches in and goes through all the way through here, and then the Satyr region has a bunch of that dark nebula as well, just all wrapping around through this whole area. And then this whole thing right here is also all dark nebula as well. So there's a lot of really cool stuff in this particular region of space. This is one of my early attempts. This is Deneb, by the way, I believe. This is one of my early attempts at this particular region, editing all the data together, and I thought I did a really good job. It's the rest of the region has a lot of hydrogen alpha, just tons of it just floating around everywhere, which is really cool. And then obviously there's the really cool Crescent Nebula here, which at my focal length I can't get a lot of good detail on, although it's a gorgeous target that has really nice features that you can get with even a modest telescope. Unfortunately, I just don't have a telescope. I just have a camera lens, and there's some really cool things. As far as I'm aware, the Crescent Nebula is a planetary nebula, I think it's a supernova remnant, and the star in the middle basically went off at some point. I think it left behind a white dwarf or a neutron star, and it's basically just been shedding shells of heavy elements as it slowly dies over time. So I'm not entirely sure about that, but I'm pretty sure, just judging by its shape and its size, that I think it is a supernova remnant of some kind. But yeah, the rest of the region is really just a bunch of ionized, gas and dark nebula blocking various forms of light. And that's pretty much the region here. It's a really fun region. When I first started imaging it, I was totally astonished as to what was really up there. I had no idea what kind of stuff was in the Cygnus constellation, and I'm really hoping I can return to it. So that's pretty much the end of my mindless rambling. So yeah, if you guys liked what you saw, go ahead and like and subscribe and all that. I'm not really good with outros yet or anything like that, but I do have a Patreon now, so if you guys want to support me, feel free to click the link down below. And yeah, I hope I can throw together more videos in the future for you guys. So yeah.